Okay, so welcome to this video. We'll be revising the test 2 for the January intake. Okay, so we have two questions in test 2. You can see the first question is this one here. There's A, B, C up to D. And then question 2 has A, B up to what? Up to C. Okay, so we're going to answer all these questions in this video. Okay, so we start with the first one there. It's saying list 4 characteristics of the continuous probability distribution. Okay, list 4 characteristics of the continuous probability distribution. So this is very easy. So the first one is that the PDF, okay, the PDF f of x is always greater than 0 for all x that you can pick. For any x that you can pick, the PDF f of x should be greater than what? Or equal to 0. And then number 2, we're going to say that the probability that x takes on a single point is actually 0. Okay, so meaning that the probability that x takes on a single point, let's say A, this should always be 0 because we are considering continuous probability distribution. Okay, and then if I have the probability that x is between A and B like this is the same as the integral from A to B of f of x and then dx. Okay, the other one, the property is that the total area under the PDF from minus infinity all the way to positive infinity, the total area under the PDF, okay, should always be what? Equal to 1. Okay. And then the other one, you can just simply say that the continuous probability distribution is represented by a PDF. So we can say this continuous probability distribution is represented by a PDF, which means probability density function. Okay, so these are the characteristics of continuous probability distribution. So you can pick any of these 4. Okay, next, they're saying a hospital monitors the time in hours it takes for a patient to recover from a specific treatment. The recovery time follows a continuous probability distribution with the following PDF. So the PDF that have been given there is f of x is equals to, okay, it's a piecewise, 2x over 9 if x is between 0 and beta, and then this PDF is 0 elsewhere. Okay, it's 0 elsewhere, meaning if x is less than 0 or if x is greater than beta, okay, the PDF becomes 0. So now, the first question here is that given that the function is a valid PDF, okay, so if something is a valid PDF, then the total area from minus infinity to infinity of f of x dx should always be equals to 1. So they're telling us there that this thing here is a valid PDF. Okay, so meaning that if I integrate from the lowest point, okay, on which it is defined to the highest point on which it is defined, I should get 1. So the lowest point here is 0. The highest point here is what? Beta. So we can find this beta. So A, we're going to say the integral, okay, from 0, which is the lowest point, to beta of 2x over 9, okay, dx. This should give me what? 1. Because they said it's a valid probability distribution. Okay, so let's integrate this guy. So if I integrate this guy to be 2x squared over 9 divided by what? 2. So we know how to integrate, right? So if I have 2x, if I integrate this, I'll just add, since this x has a power 1, I'll add a 1 to this power and then divide by the new power like this. So this is what I've done there. Okay, put it, this x was to the power 1, I've added a 1, it will become 2. So I divide by that same thing here. And then I have the limits from 0 to beta. And this should be equals to what? To 1. Okay, so let's substitute now the beta into this thing. So first of all, we can see that these 2 and these 2 are going to cancel. So I mean with x squared over 9. So if I put beta there, it will be beta squared over 9, then minus. If I put 0 there, it will be 0 squared minus 9. This should be equals to 1. Okay, so this will just mean beta squared over 9 is equals to what? 1. Cross multiply, I'll have beta squared is equals to 9. So I'll take the square root of this side, square root of this side. So it means my beta will just be equals to what? 3. Okay, so I can take minus 3 there because this thing here has to be a positive value because this is 0. So whatever I have there should be positive. So the beta there, I found that it is what? 3. Okay, so the beta is 3. We found it. And then we can now rewrite our PDF in this form since we've done the beta now. So we're going to write it somewhere here. We're going to say f of x, yeah. Okay, we're going to say f of x is equals to the piecewise function 2x over 9, 0. So here it will be from 0 all the way to what? 3. And then here it will be 0 elsewhere. So the beta found it is 3. Okay, so B. We look at B now, they're saying find the time, find the mean recovery time for the patient. So here we're just finding the expected value of x. So expected value of x will be equals to the integral from 0 to 3 of x multiplied by f of x. So f of x is this 2x over 9 and then dx. Okay, so meaning that we have what here? We have the integral from 0 to 3 of 2x squared over what? 9, then dx. So to evaluate this, we can take the 2 over 9 outside the integral. So it will be 2 over 9. And then we have the integral from 0 to 3 of x squared dx. Okay, so this will be equals to, so we can now integrate here. So this is x squared. So to the squared or to this 2, I add 1. Okay, then I divide by that new power. So it will be 2 over 9. And then inside the brackets there to be x to the power 3 divided by what? 3. So I increase this power by 1. And then from 0 all the way to 3. So this is what I have. And then now it will be 2 over 9. Okay, and then 3 there. It will be 27 over 3. Okay, minus 0 to the power 3 over 3. So this meaning that we are going to have what? We're going to have 2 over 9. And then here, 3 there, it's 1. 3 there is what? 9. So here I'm just remaining with 1 over 9. 9 over 1, I mean. So we see that the 9 and the 9 will cancel. So I'm just going to have what? 2. So the expected mean recovery time is what? 2. Okay. And this time is being measured in hours. So this means the mean recovery time is actually what? 2 hours. Okay, so we can put it somewhere here. The expected value of x, which is the mean recovery time, is just what? 2 hours. This is how to calculate it. Okay, now we go on C. C, they're saying determine the standard deviation of the recovery time. So for us to find the standard deviation, we need to find the what? The variance of x. But the variance, okay, of x is equals to the expected value of x squared minus the expected value of x, and then we do what? We square it. So we're going to say expected value of x squared is equals to, okay, the integral from 0 to 3 of x squared multiplied by the PDF and then dx, like this. Okay, so this we're going to have the integral from 0 to 3 of 2x to the power 3 over 9 dx. So we've multiplied this x squared with this 2x. And then here factorize the 2 over 9. So we have integral from 0 to 3 of what? X to the power 3 dx. So we can now integrate that one. So it will be 2 over 9 outside. Then in the brackets, I integrate this x to the power 3. So it becomes x to the power 4 over what? 4. And then I have the limits from 3 to 0. So this will be 2 over 9. Okay, 2 over 9. And then I can put the 3 there. So it will be 3 to the power 4 over 4. If I put 0 there, to just be 0. So this is what I have there. Okay, that is what I have there. So we just use the calculator there now. So it will be 2 divided by 9, okay, multiplied by 3 to the power 4 divided by 4. Okay, so this gives me 4.5 as my expected value of xc squared. Okay, so meaning we can now find the variance. Okay, so the variance is the expected value of x squared, which is this. So 4.5 minus the expected value of x squared, which was 2. So it will be 2, and then I square it. So this will be 4.5 minus 4. So this will just lead to what? 0.5. So the variance is 0.5. But remember, our equation asked us to find the standard deviation. So the standard deviation is always the square root of the variance. Okay, so you get your calculator. It says square root of 0.5. So square root of 0.5 to be 0.70716. 0.6781. So this one here is the standard deviation. Okay. Okay, and then we go to D. I can erase this. So here, this is D. So D, they're saying find the median. Okay, so how do we find the median? We find the median, okay, by equating our PDF to 0.5. Because remember, when you talk about the median, then we are dividing our data into two equal parts, right? Okay, so the median M, okay, such that the probability that X is less than or equal to this median should be equals to 0.5. So this is how we find the median. So we're going to say this probability here is just simply from 0 all the way up to M. Okay, because they're saying X is less than M. So it is the integral from 0 up to M. This one here is the median that you want to find. And then we have the PDF there over 9, like this. Okay, and then dx, this here should be equal to 0.5 because we are finding the median. Okay, so we can take the 2 over 9 outside. And then 0 to m of x dx, okay, is equals to 2 over 9. And then we integrate this now. So x becomes x squared over 2. And then manje, we are moving from 0 to m like this. So it means what we're going to have is 2 over 9. Okay, don't forget this is equals to 0.5. I just don't have space there. I can just write it in front. Okay, so 0.5 is equals to, and then here I substitute. So it's going to be m squared over 2, k minus 0 squared over 2, like this. Okay, so what are we going to have there? We're going to have 2 over 9 in the brackets of m squared over 2 is equals to 0.5. Okay, 2 and 2 cancels. I have m squared over 9 is equals to 0.5. So this will be m squared of is equals to, so I can cross multiply. So 9, okay, 9 multiplied by 0.5, it will give me 4.5. Okay, and then I take the square root of both sides. So m will just be equals to the square root of 4.5, which is giving me 2.1213. So this one here is my median. Okay, so my median recovery time is just about 2.1213 hours. So that's how we find the median. We equate it to 0.5. Okay, let's look at E. E, they're saying, what is the probability that a randomly selected patient will take at least 3 hours to recover? So we are finding the probability that X will be, they said at least. So this will be greater than or equals to what? To 3, like this. So what I can do here is that I can use the complement rule to say that this is the same as 1 minus the probability that X is greater than what? That X is less than 3. So this will be 1 minus, here to be 0 to 3, okay, of 2x over 9 dx. So now what we notice here is that this guy here, okay, it's just the total area under the defined region, because we said the defined region is 0 to 3. So always when you are integrating over the whole region that you have there, this is 1. So this is 1 minus 1. So this will just be equals to what? To 0. So the probability that X is at least 3 hours, takes 3 hours to recover, is 0. Okay, if you want, you can evaluate this. You're just simply going to find 1. Okay, so the answer there is 0. I go to the next question, which is question C. And this one here is on the uniform distribution. So that's saying Kitwe General Hospital schedules routine checkups for patients uniformly between 8 hours and 5 p.m. Okay, so we know that this is just simply 8 hours, of course. And then the 5 p.m. it's 17 hours. Okay, so write down the probability density function of Kitwe General Hospital. So we know that if X follows a uniform distribution, okay, between A and B, then the probability density function P of X, so it can be F of X, will be equals to, okay, 1 over B minus A if X, okay, if X is between A and what? And B. And then it will be 0 elsewhere. So this is what we're going to use. So now here they have said between 8 and 17 hours. So it means my interval is 8 to what? 17 hours. So here I'm going to say X follows a uniform distribution with A being 8 with B being 17. So it means my PDF will just be equals to what? Okay, to be 1 over the B is 17 minus 8 if my X is between 8 and what? 17. And then it will be 0 elsewhere. Okay, so that is going to be my probability density function of the Kitwe General Hospital. Okay, so I can even write it somewhere here. So I'm just going to write P of X or F of X is the same. 1 over, what is 17 minus 8? That will be 9. So that is if X is between 8 and what? 17, then 0 elsewhere. Okay, so that is the answer on question number A. B, what is the probability that the waiting time for a checkup is at most 13 hours? So here we're finding Okay, that is B1. We're finding the probability. They said at most. So meaning that X should be less than or equal to what? 13. So this is the probability that we are finding. Okay, we're finding the probability that X is less than or equal to what? 13. So how do we do it under the uniform distribution? Okay, so we check this number here. This number is between 8 and what? 17. And then from since they said it should be less than 13, okay, so meaning that we are starting at 8 and then we are ending somewhere at 13, right? So this probability will be the same as, okay, will be the same as where I'm starting from, which is 8, okay? You subtract it from the 13. So it will be 13 minus 8 divided by the total length of this interval, which is 17 minus what? 8. So this will be 13 minus 8 gives me 5. 17 minus 8 gives me 9. So I can divide this to get 0.5556 as my probability. 2, they're saying find the probability that the waiting time for a checkup is at least 13 p.m. So this means at least should be greater than or equals to what? To 13. Okay, so now since here we have a greater than, then it means we can't start. Uh, mm, oh, see, since here we're the distance, right? So the highest value we could get is 13. So that's why we did 13 minus the lowest. But here, since we are doing greater than 13, then the highest value that we can get in this interval should be 17. So it will be 17 minus 13 over, down here, it doesn't change. It's just the length of the whole interval. So I'm going to say 17 minus 13 divided by 9. Okay, so that will be 4 over 9. So this one gives me 0.4444. So that is the probability under the uniform distribution. Okay. All right, so that is B. And then C, they are saying we calculate the expected value, okay, of the waiting time in hours for a checkup. So under the uniform distribution, the expected value is not difficult. So you're going to say expected value of X will just be equals to A plus B over 2. This is the formula. So what is our A? Our A is 8. So it will be 8 plus our B is 17 over 2. So this will give me what? So this will be 8 plus 17. That will be 25 over 2. So I divide 25 divided by 2. I get, okay, my calculator is saying 12.5 hours. So this one here is the waiting, it's the expected waiting time in hours for checkup of patients or for patients. Okay, and then D, calculate the standard deviation. Okay, so to calculate the standard deviation, we just need the what? We just need the variance, guys. Okay, so under the uniform distribution, the variance of X is given by this formula. It is B minus A squared, okay, over 12. This is the formula. So memorize this formula under the uniform distribution. So my A is what? It's 8, my B is 17. So it will be 17 minus 8, and then I square it, I divide by 12. So this will be 17 minus 8, that will be 9. So 9 squared on top there. Okay, 9 squared on top divided by 12. Yeah, 9 squared divided by 12. I'm getting 6.75. So this is the variance. So the standard deviation is just the square root of 6.75. Square root of the answer, I get 2.5981. So this one here is the standard what? Deviation. Okay, this is the standard deviation. Okay, so it means we are done here with question D. Okay, we're done with question D. Let's go to the next question. Okay, so now let's look at question D. Okay, let's look at question D. So question D is on the exponential distribution. Okay, so they're saying in a hospital emergency department, the time in minutes between patients' arrivals follows an exponential distribution where on average, one patient arrives every 20 minutes. Okay, so this one here, they're saying on average, one patient arrives every after what? 20 minutes. So that means the mean here, or the expected value, or the mean, or the average is just what? 20 minutes. Okay, so A, they're saying, what is the probability density function of the hospital? So the probability density function, we've already been told that this is an exponential distribution. Okay, so we just have to write the PDF for an exponential distribution. So the PDF for an exponential distribution, f of x, okay? So if x follows an exponential with parameter lambda, then its PDF will be given by 1 over lambda, and then e to the power minus lambda x, like this, okay? Where the x should be greater than or equals to what? To 0. This is the PDF, okay, for the exponential distribution. So we just have to find this lambda. So this lambda here is found by 1 divided by the mean. So we see that the mean there is what? It's 20. So it will be 1 over 20. So this is our lambda here. So it means our PDF will be f of x is equals to 1 over 20. Oh, no, no, no. Don't be 1 over 20. Because we said oh, yeah, it will be, oh, so I made a mistake here. So the PDF here, it has lambda, not 1 over lambda. Okay. Here it has lambda in front, and then e to the power minus lambda x. And then the x should be greater than 0, right? And then here I was finding the lambda. So lambda is 1 over the mean. The mean is 20. So lambda will just be 1 over 20. So this lambda here to be 1 over 20. And then I have e. This lambda again, it is 1 over 20. And then x. And then x should be greater than or equal to what? To 0. Okay, so that's the PDF for this exponential distribution. Okay, so let me write it somewhere there so that we can be using it. So say f of x is equals to 1 over 20 e to the power minus 1 over 20 x, and then x greater than or equals to 0. Okay, so this will be our PDF. Okay, and then remember our expected value again was 20. Okay, let's look at B now. So B, they're saying, what is the probability that the time between two consecutive patients' arrivals is between 10 and 30 minutes? So meaning that we are finding the probability that the time of arrival, which we said was x, which follows the exponential distribution, okay, is between 10 and what? 30, like this. So here it means we are just integrating between 10 and 30. But we can also find this using the CDF. Okay, so this will be the integral from 10 to 20 of our PDF. Okay, so we can find it using this. So we can say the 1 over 20 goes outside. So it will be 1 over 20. Then I remain with the integral from 10 to 30. I don't know why I wrote 20 here. And then I have e to the power minus 1 over 20 x dx. Okay, so this is what I have, right? So here I have to integrate the e. So how do you integrate the e? Okay, you find the derivative of the power. Okay, you divide, and then you divide this same thing by that. So it will be 1 over 20 multiplied by, okay, I'm going to say this same thing, okay, and then I divide it by the derivative of the power. So if I differentiate this power here, what am I going to get? I'm going to get minus 1 over 20. Okay, which will just be the same as this 1 over 20. I keep it. If I'm dividing this thing by 1 over 20, it's the same that I'm multiplying by 20. But now it is a minus there, okay, over 1. Then e to the power minus 1 over 20x. Okay, so that is my integral of this guy here inside. Okay, and then I'm multiplying it by 1 over 20. And remember, we are coming from the limits 10 to 30 like this. So this is 10 to 30. Okay, so it means you can see this 20 and this 20 cancel out. So what I have there will just be minus e, okay, to the power minus 1 over 20 x, and then the limits are 10 to 30. So I can substitute now. So it will be minus e to the power minus 30 over 20 minus e to the power minus 10 over 20. Okay, so what does that give me? This gives me negative and negative. It will be a positive, minus 10 over 20 minus this one, minus 30 over 20. Okay, so what does that give me? I just go on my calculator. Okay, I go on my calculator and then I punch that value to find the final answer. Okay, so when I punch that, e to the power minus 10 over 20, and then minus e to the power minus c. Maybe you can just reduce this before you do on the calculator. So e to the power minus, what is 10 over 20? I get 0.5 minus e to the power minus 30 over 20, I get minus 1.5. So we can easily punch this now on the calculator, right? So when I do that, I find that my probability is approximately 0.3834. So try it out, okay, on your calculator, see that you get this. So this is the first way in which we can get the probability that x is between 10 and 30. So we are integrating. But if we want, we can use the CDF. Okay, so the CDF of an exponential distribution is given by what? Okay, the CDF of an exponential distribution is given by 1 minus e to the power minus lambda x. But remember, my lambda was 1 over the mean. The mean was 20, so it was 1 over 20 like this. So we can also use this CDF to find this probability. So if we use this CDF, okay, we're going to say this here is the same as the CDF of 30, the bigger number, minus the CDF of 10, the smaller number. So here, my x now is 30 there. So it will be 1 minus e to the power minus 1 over 20, which is the lambda. And then the x is what? Is the 30. Okay, so this is what I have. And then minus this f of 10 again, I use the same formula, 1 minus e to the power minus 1 over 20. I'm multiplying it now by the x, which is what? 10. So you see that even from here, I'm going to, okay, so this is be 1 minus e to the power. This will be minus 30 over 20. Then this one will be minus 1. This one will be plus e to the power minus 10 over 20 like this. So you see that 1 and minus 1 cancels out. And then I still remain with e to the power minus 10 over 20, which is minus 0.5, minus this guy here, minus 30 over 20, which is e to the power minus 1.5. So we are going to get the same answer. So if you don't want to integrate, you need to know the formula for the CDF, this guy here. But if you want to integrate, you can do the first approach that I did. Okay, but both of them are actually going to give you the same answer. Okay, so that is about B, this one here. Let's look at C. So C, they're saying the probability that the time between arrivals exceeds T minutes is considered a surprise for the hospital without receiving a patient, as it rarely happens. Okay, so this probability is approximately 0.1353. Find the value of T to one decimal place. So here they're saying the probability at the time, okay, between arrivals exceeds T. So meaning that we are finding the probability, okay, that this X exceeds a certain value of T is equals to 0.1353. So they want us to calculate this value of T there. Okay, so how are we going to calculate it? Okay, we're going to use the CDF. So remember, I said the CDF of X is equals to 1 minus e to the power minus lambda t, right? But this CDF simply means the probability that X is less than or equals to T. Okay, it's the same as this. So what I'm going to do here is that here I'm going to apply, first of all, the complement rule. So if X is greater than T, this is the same as 1 minus probability that X is less than or equal to what? To T. And then this is equals to 0.1353. Okay. And then this part here is equals to the CDF, okay, which is f of X, and f of X is equals to this. So I'm going to replace there where I have this part here. I'm going to replace it with the CDF, which is this. So it will just have 1 minus, and then in the brackets, I have 1 minus e to the power minus lambda t, okay, which is equals to 0.1353. So it will be 1 minus 1 plus e to the power lambda t is equals to 0.1353. So we see that these guys are going to be 0 because that is 1 minus 1. So I'm just remaining with e to the power minus lambda t is equals to 0.1353. So here I can introduce ln on both sides. So I'll say ln here, ln that side. So this ln allows me to drop this power in front. So it will be minus lambda t and then ln e, which will just give me 1, is equals to ln 0.1353, like this. Okay, so this ln e will give me 1, so that is just 1. And then I can divide both sides by minus lambda. So it means t will just be equals to 1 divided by lambda. And this lambda came with a minus, so I have a minus there. And then ln of 0.1353. So this will be, what is the lambda? Remember, lambda is equals to 1 over the mean, which is what? 20. So here it will be minus 1, this one on top, divided by, this lambda here is 1 over 20. Then I'm multiplying by ln 0.1353. So this will be minus 20 multiplied by ln 0.1353. So we just punch this onto the calculator and see what we're going to get. Okay, so I get approximately 40.005. So they said to one whole number. So if I round this off to one whole number, I get that my t will just be 40 minutes. Okay, so that is it about question 1. Okay, that is it about question 1. We now go and solve question 2.